This question is on sound waves. The question says a man stands between two tall buildings, P and Q. He is 50 meters from P and 200 meters from Q. Here we can see this is the building P and building Q. That's the man standing here, 50 meters from P and 200 meters from Q. He sounds a horn. He hears the first echo from building P, and one second later he hears the first echo from building Q. What is the speed of sound? Calculate it using this information. In a given question, generally, when sound is reflected from a plane surface, the speed of sound is given as V is equals to 2x all over t. That means the distance is twice. It reflects to and fro and come back. If, for instance, you have this is a source of sound and this is a plane wall, when the sound reflects on the wall, it will come back to the source. This is the distance x from the source. So as the time duration is the distance is twice the time it will reflect back. Echo from building P. The echo from building P, we consider the echo received from building P. Then the speed will be expressed as 2x all over Cp. P is the time to reflect on building P back. And in this situation here, x, the distance is 50 meters. And T, and Cp is T in this aspect, the time for it to reflect in building P. Let's imply that if we solve for V, that become 2 times 50 all over T. That will give us V is equals to 100 over T. We'll need that equation. This is one of the equations we'll consider. So I'll put that in a box. Now we also consider echo from building Q. Likewise, we use the same equation. But this time around, the speed becomes 2x all over TQ. Here x is 200 meters, and TQ is t plus 1. Because 1 second later from the question it reflects from here. It said 1 second later he's here the first echo from building Q. Putting this into the equation, let's imply that V is equals to 2 times 200 all over T plus 1. T plus 1. The final expression for this will give us 400. 2 times 200 is 400 all over T plus 1. This equation will also be needed. The first equation that we put in the box and the second equation we put in the box, they all give an expression for the speed. So that means if we say the first equation, the speed is also equal to the speed in the second one, that gives us the room to equate both equations. That is 100 all over T plus 1 100 all over t will be equal to 400 all over t plus 1. We simplify, arrange the equation. That will give us 100 bracket t plus 1 is equals to 400 t. Open the bracket will give us 100t plus 100 is equals to 400t. I will solve and move to the next page. Simplifying further will give us 400 t minus 100t is 100, and it's 300t. We simplify 400t minus 100 to give us 300t is equals to 100. Making t the subunit formula, that is 100 all over 300. That makes t, the time, 0.33 seconds. We are looking for the speed. One of the equations that we put in the box, the first one, says that the expression gives us v is equals to 100. V is equals to all over t. Substitute t there. That's 100 divided by 0.33. Using a calculator, that will give us 300, approximately 300 meters per second. So this is from the calculation, this is the speed of the sound.